This is lesson 5.1 in trigonometry, fundamental identities. And one of the things that you're going to learn about this chapter is that I am not going to be a real stickler for you understanding everything in this chapter and being able to just tear through these problems. This is a pretty challenging chapter, and I expect you to keep your trig solution key handy as you go through these, because it's going to be very important for you to be able to use that. Kind of like story problems. Once somebody does story problems on the board for you, you're able to see how they get the answer. But if you're just thrown into them and doing them by yourself, it's really hard for you to just come up with the answer by yourself. And that's kind of the way these fundamental identities are. And so the ones that I have here on the screen are ones that you've had since chapter 1. And because remember, your calculator does not do cotangent, secant, or cosecant, you have to change them to the reciprocals in order to do that. So if you were looking for the cotangent of 30 degrees, that would be 1 over the tangent of 30. So you would just, instead of writing the cotangent of 30 or trying to put that in your calculator, you'd do 1 divided by the tangent of 30, and that would equal the cotangent of 30. So those are necessary for you to have in your notes. This other table here, and I'm not going to go over the y's on how they derived all of these different formulas, but let's just look at a couple. We've got sine squared theta plus cosine squared of theta equals 1. One of the things that you need to realize about these is those can be rewritten. I can subtract cosine from each side and get 1 minus cosine squared of theta. So remember, that's a possibility. And I can also subtract my cosine squared of theta, or I can subtract my sine squared of theta and get cosine squared of theta equals 1 minus sine squared of theta. So I put those two down in your notes as well as this one, because those are just another alternative form of that identity. So this list that we have here, we've got my Pythagorean. We've got that is also a Pythagorean, and this is a Pythagorean. And we've got negative angle identities. So the sine of negative 30, and if you remember what that means, is it means that you're just starting here at your initial side and going this way around, and that's how you'd have a negative theta. So let's say that you're down here, and that theta, that angle, is negative 120 degrees. So if we took that and put it in here to find the sine of negative 120 degrees, that's basically saying we're going to find the sine of 120 and then take the negative of it. So that's what these identities are talking about here that they're going over. So again, put those in your notes, have them available for you because you will be using those. So let's just kind of tuck these away right now as we look at some of these examples here. So let's make those smaller so we can just kind of have them up here ready for us. Alright, so we're going to just start with some examples, and we're going to start with example 1, and they're saying if we have the tangent of theta, so if you take the tangent of some angle, you're going to get negative 5 over 3. And theta is in the second quadrant. So what we're saying here is that tangent is opposite over adjacent. So I know that if it's in the second quadrant, the negative actually is on the 3, not the 5. Because they give you negative 5 over 3, and they put that negative sign right there in the middle. Well, the negative is actually, if you're talking second quadrant, you're talking this quadrant right here, and you're also using opposite over adjacent. Well, in the tangent, the opposite is going to be in the positive direction. Your y value is going to be 5. It's the opposite. My x value, on the other hand, is going to be 3, but it's going to be negative 3 because I'm over in the second quadrant. So I know that I'm going to have a negative 3 there. All right, so let's say that's our angle. What they're interested in doing is finding, it says A, finding the secant of theta. So what is the secant of theta? Well, you know that secant equals 1 over the cosine of theta, right? So if secant equals 1 over the cosine, then what is the cosine of theta? Cosine would be opposite or adjacent over the hypotenuse. So you find the hypotenuse and you'd have 1 over whatever the cosine of theta is, and that would be your secant. That's how we've done it in the past, and it's a good way in order to find it. But the book is trying to use identities to find answers to this, so we're going to throw out the graph and do it the way they say. Alright, so one of the things that we're going to do is they're asking you to find the secant of theta. So when they ask you to find the secant, they're asking you, especially using identities, to look for an identity that relates both tangent and secant together so that mathematically we can figure this out. So looking up here at this list that I have above, we find out that this one right here relates both tangent and secant. Tangent squared of theta plus 1 equals secant squared of theta. Well, let's plug some stuff in. So tangent squared of theta would be this, and then square it because it says tangent squared of theta, and then it says add 1, and that's going to give us secant squared of theta. So what we're looking for, we're trying to find out what value secant is. That's what they asked us to find right there. Keep going. We're going to square your negative 5/3, and we're going to get positive 25 over 9. We're going to add those. And I'm assuming that you're not going to have any problem finding common denominators and adding those together and getting 34 over 9. Okay, next step is take square root of both sides. So square root of both sides gives us plus or minus square root of 34 over 9 equals secant of theta. Okay, now we've got a plus or minus. One of the things that's important, and I'm going to erase a bunch of stuff over here since we don't need this anymore. That was just to get to where we're at right now. One of the things that's important to realize is which quadrant we're in. That's why they told us what quadrant we're in, is so that we know that we have a triangle over here. And so what we're looking at finding out is the secant positive or negative in the second quadrant? All students take calculus. Second quadrant, sine and cosecant are positive in the second quadrant. The rest of them are negative. So that means I don't have a plus or minus, it means I have a negative. Okay, because it's going to be negative in that quadrant. So I can't leave this way. So I'm going to rewrite it as negative square root of 34 over the square root of 9, which is 3, equals secant of theta. So that ends up being our answer there. Alright, the next part of this is asking us to find the sine of theta. So given that the tangent of theta is negative 5/3, we're going to try to find the sine of theta. Alright, so same thing. We're going to look at the same thing. We're trying to find out if there's anything that we can bring together, or any of these formulas up here that we can use that are going to put our sine and tangent together in some way. Okay, and let's see. Tangent and sine together. I would say probably this one right here. Tangent of theta equals sine of theta over cosine of theta. Now what are we looking for? We're looking for the sine, so we need to isolate that sine by putting the cosine over here. Okay, the way we did that, let's do an algebra equation completely different than what we've got there. And we've got 4 equals 3 over x. What do we do with that? We multiply both sides by x, and we have 4x equals 3, right? Because those cancel. So we took our number that was underneath in the denominator and multiplied it over here. And it just simplified it. We don't have a fraction anymore. That's exactly what I did here. I just took this, multiplied both sides by cosine of theta. The cosines canceled here, and we have a cosine over there now. So nothing weird, but you might not have just noticed that we were just doing regular algebra to find that. Alright, so now I've got cosine of theta times the tangent of theta equals the sine of theta. One of the things that I do know is that I found this answer in part A, and the cosine of theta is actually 1 over the secant of theta, right? And it says that right here. Okay, secant of theta is 1 over cosine, or cosine is 1 over secant. Either way, you can flip these two around here. And that's where I got that. Alright, so now I can replace my secant of theta with this number there. So I'm going to put 1 over square root of 34 over 3. Let's kind of make that a thicker line so I know where the fraction is. And then I'm going to multiply that by the tangent of theta, and that equals my sine of theta. Alright, what do I know about the tangent of theta? Well, I know the tangent of theta, I mean it's right here, is negative 5/3. Alright, so let's flip this around, and that will change to negative 3 over the square root of 34. And, well, let me show you how we got that. Alright, let's slow down here. Alright, when you're dividing here, you've got a number here and a number here. When you divide by a fraction, you take this, flip it upside down, and multiply it. So I flipped it upside down and multiplied it by 1. Okay? And then I multiply it by negative 5 over 3 equals the sine of theta. But I can't have a radical down here. So eventually that's going to change. In fact, let's just change that right now. And in order to change it, you take negative 3 over the square root of 34 times the square root of 34 over square root of 34. And that gives us negative 3 square root of 34 over 34. So this is what we're going to put in place of that. So let me erase all that work that I did there just to get the answer to replace this with right here. So that is negative 3 square root of 34 over 34 times negative 5 over 3. And that equals my sine of theta. Alright, let's multiply this. So I have negative 3 times negative 5 is 15, square root of 34, over 34 times 3. But you know, I just noticed something. I have a 3 here and a 3 here, so I can just cancel. So I get, I didn't cancel that negative though, so I have a negative and a negative, so I have positive 5 square root of 34 over 34, and that ends up being my sine of theta. Alright, again, hopefully you can see what I did in order to get this. I don't expect you to be able to figure it out on your own. These are really difficult to do. Okay, let's look at the C part. Get rid of all my stuff here. Okay, C is asking us to find the cotangent of negative theta, or gosh, let's see, how can I associate or relate tangent to cotangent? Let's see here. Oh, right here. I've got a relationship there. So I'm going to write that equals 1 over the tangent of negative theta. Okay? I mean, I've got a negative theta here, cotangent of that, and that's going to equal 1 over the tangent. Because it just says the angle. Well, they don't care if the angle is negative or not. They just said cotangent of the angle is the same as 1 over the tangent of that angle. So that's what we did here. So, one of the things that we also know from this formula right here is that the tangent of negative theta is the same as negative tangent of theta. And what did we know? What do we know about the tangent of theta? Well, the original problem says that theta is in quadrant 2 and it's negative 5 over 3. So that is the tangent of theta. So that's what we're going to put right there. Alright, so I'm going to write this as 1 over negative 5 thirds, because I've got a negative out here that's here, and this tangent of theta is this negative, so they've got that. So that gives me that, and because it's divided by a fraction, I invert and multiply, and I get 3/5 for my cotangent of negative theta. And I'm done there. Sounds easy, doesn't it? It looks like, oh yeah, that's not too bad, but when you try to do these on your own, it about kills you. Alright, so we'll do a couple more examples in the next video.